Welcome to our tutorial on setting up a WireGuard VPN. If you are new to VPNs, don't worry, we will guide you through the process step by step. The first thing you need to do is update your system. To do this, open up a terminal and run the following commands: apt update and apt upgrade. Next, we will need to install the required packages for WireGuard. We will install WireGuard for VPN, Nano for editing, and IP tables for routing packets. Be sure to like and subscribe this channel if you want to see similar content in the future. Next, let's change into the WireGuard directory by typing cd WireGuard and hitting enter. Now we will use curl to get the public IP address. Type curl ifconfig.me and hit enter. This command will use the ifconfig.me website to retrieve your public IP address and display it on the screen. Take note of this IP address as you will need it later. Next, we will create the server public and private keys. We will use the WireGuard module to generate the key pair. Write this key pair somewhere else so we can use it later. Type the following commands to generate server private and public keys. Once the keys have been generated, save them in a separate file so we can use them later. The VPN server will listen on port 51820. To find out your network interface, type ifconfig command in your terminal. We will then create a server configuration file. The convention is to use wgo.conf naming standard for each interface, and we will stick to this. This file will contain information about how to set up a VPN server. Copy the following code into the file and change the parameters accordingly. Remember to change it according to your own settings. After you are done, press Ctrl S to save and Ctrl X to exit. The post-up command will run when the WireGuard server starts the VPN tunnel and executes the commands. Next, we will perform port forwarding in your network router. This step is supposed to be different depending on your ISP and the router you are using. Typically, there is a feature called port forwarding or port redirection in your router homepage. Be sure to forward all your traffic from port 51820 to the local IP of the VPN server, which in this case is 192.168.1.32. Once you are done, we will enable IP forwarding in the Linux kernel so that the kernel can forward packets to the WireGuard network interface. One last step to configure the server is to set up the proper firewall rules. This will allow the raw packets to pass through the firewall. We will use the UFW module in Linux to allow port number 51820 through the firewall. We can also set up the VPN server to automatically start at the boot, so we don't have to start it manually every time we boot our system. Run the following commands to set up a service to restart at boot. We are finished setting up our server. As you can see, our VPN network interface is up and running and it has been assigned an IP address. Let's switch to the client side now. The steps are going to be somewhat similar as there is no inherent difference in WireGuard between a server and a client. WireGuard considers both server and clients as peer nodes, so there is no inherent difference between a server and a client. Similar to the server, let's now create public and private key pair for the client side. Run the gen key and public key command to generate public and private keys for the client. We will use these keys to establish connection with the server. Copy these keys to a separate document so we can use them later to create a configuration file for the client. As we did for the server, we will create a wgo.conf file for the client. Copy the following text into the file and modify the parameters accordingly. Read the private keys. The VPN IP for this client will be 11.0.0.2. Endpoint is the server public IP address. Finally, we need to register the client to the server with the help of client's public key. We will use the following command to register the client to the server. WireGuard is a client-initiated protocol. This means that you must register each client to the server with its public key, otherwise the connection will not work. Let's test the connection to see if everything works as expected. The client's IP address is 11.0.0.2 while the server is 11.0.0.1. Within a VPN network, these two devices will be accessible through these addresses as opposed to their local IP addresses. Let's ping the server from the client and the client from the server and see if we get a response back. If we get a response, it means that the VPN connection has been established successfully. Now you can access the server from anywhere in the world as if it was connected directly to your local network. I hope you liked this video. If you want to see similar content related to networking and open source projects, be sure to like and subscribe to this channel. See you in the next video.